Good morning, students. In the last class, we have discussed with reactions of alcohols with halogen acids or hydrogen halides. So, in today's class, let us discuss the reactions with phosphorus halides. So, let us continue the discussion with reactions with phosphorus halides. So, when we discuss the reactions with phosphorus halides, the reactions with phosphorus halides are of two different types. One is with phosphorus trihalides, another one is with phosphorus pentahalides. So first, let us discuss the reaction of alcohols with phosphorus trihalides. So when it comes to phosphorus trihalides, when an alcohol is made to react with phosphorus trihalides, always we are going to get alkyl halide along with the formation of H3PO3, because this we have already discussed with haloalkanes as well as haloarenes. So this is called as what? Phosphorus acid. Here the halogen can be either chloro, or it can be bromo, or it can be iodo. So here in the same way, when we take a particular example of methyl alcohol, so when this methyl alcohol is made to react with PCl5, so here 5 halogen atoms are there. So due to this reason, 3 moles of alcohol will be involved in a chemical reaction, where this 3 moles of alcohol combines with Cl, so to give 3 moles of CH3Cl along with the formation of H3PO3. So here, apart from using, this is PCl3, sorry, so here this will be PCl3. So 3 moles of alcohol combines with 3 moles of PCl3 to form 3 moles of methyl chloride along with the formation of phosphorus acid. Suppose if I continue the same reaction with another alcohol, that is C2H5OH, upon reaction with PCl3, so 3 chlorine atoms will combine with 3 moles of alcohol, which will give rise to 3 moles of C2H5Cl along with the formation of H3PO3. In the same way, the reaction of PBr3 as well as Pi3 also takes place. So this PBr3 can also be written as P plus of Br2, means the combination of red phosphorus along with Br2 or PBr3, both are same. Or Pi3 can also be written as P plus of I2, means the combination of red phosphorus along with iodine is nothing but Pi3. So here both can be used during the course of a chemical reaction. Either we can use PBr3 directly, or we can use the combination of red phosphorus along with bromine, or else we can also use Pi3 directly, or the combination of red phosphorus along with iodine. So this is the method how an trihalide is involved in a chemical reaction. Now let us write one particular reaction based upon this combination. Suppose if I use methyl alcohol, so when this methyl alcohol is made to react with phosphorus, that is nothing but red phosphorus in the presence of bromine. So here what happens? This should be bromine along with 2. Here 2 moles of phosphorus will be involved, and here 3 moles of bromine is involved, such that so 6 bromine atoms are there. So due to that reason, this will be 6 moles of an alcohol, which will give rise to 6 moles of CH3Br along with the formation of H3PO3, which will be of 2 moles. So this is the method how P plus of Br2 or PBr3 can involve in a chemical reaction. Suppose apart from taking 2P plus of 3 moles of Br2, if we write the reaction with methyl alcohol along with PBr3, so here 3 bromine atoms will combine with 3 moles of alcohol, that will give rise to CH3Br 3 times plus of H3PO3, means the product will be identical either if we take the combination of red phosphorus along with bromine, or else PBr3. Suppose if we discuss the same reactions with relevance to pentahalides. So, when pentahalides is involved in a chemical reaction, for example, when an alcohol is made to react with PX3, which will give rise to, so here we know that pentahalides. So if it reacts with, if it reacts with PX5 pentahalides, so that one particular halogen will combine with one alkyl group, one halogen will combine with one hydrogen, which will give rise to RX plus of HX. What is left out? Still one oxygen is left along with three halogen atoms, that can be written as POX3. Suppose if I use a particular example, this POX3 is called as phosphorus oxyhalide. Apart from using this, if I utilize CH3OH, that is methyl alcohol, when it is made to react with phosphorus pentachloride, so here one chlorine atom will combine with methyl, one more chlorine atom will combine with hydrogen, that will give rise to CH3Cl plus of HCl plus of POCl3. Suppose if I take reaction with PBr5 and reaction with PI5. So here, as we have taken PBr3 and PI3, suppose if we discuss the reactions with PBr5 and PI5, remember this PBr5 and PI5, they does not exist. Only PCl5 can exist during the course of a chemical reaction. So this is the entire explanation when an alcohol is made to react with phosphorus trihalides as well as phosphorus pentahalides. When phosphorus trihalides is involved in a reaction, phosphorus acid will be obtained. Whenever a pentahalide is involved in a reaction, phosphorus oxychloride is obtained. After knowing this, one more most important concept that has to be known in alcohols, phenols and ethers is dehydration reaction, which is very important. So here one should know the concept or the meaning of dehydration. So here dehydration means it is nothing but removal of water molecule is called as dehydration. Here in this dehydration reaction, concentrated sulfuric acid will act as dehydrating agent. So when a chemical reaction is involved, here let us consider an alcohol. So you know this is nothing but what? Ethyl alcohol. So when this respective ethyl alcohol is made to react with concentrated sulfuric acid by maintaining a temperature of 433 to 443 Kelvin. So here OH gets eliminated. So this is the functional group. This carbon is called alpha carbon. This carbon is called beta carbon. The hydrogen gets eliminated from the beta carbon such that when OH goes out with entire bond pair of electrons, this carbon becomes electron deficient. Hence, this bond will shift at this site so that we get the major product as ethene, where there is a removal of water molecule due to the presence of concentrated sulfuric acid, where this concentrated sulfuric acid is considered as a dehydrating agent. So this is the reaction how an alcohol is converted into an ethene. So for this respective dehydration, there is a mechanism. So many times this question has been asked for 3 marks in the board. Be careful with this. So very important question. So when it comes to mechanism, the mechanism readily takes place in 3 different steps. So the first step is, step 1 is called as alcohol. Means ethyl alcohol will react with ethyl alcohol reacts with proton, that is nothing but proton which is obtained from mineral acid, and the mineral acid utilized here is what? Sulfuric acid, to form protonated alcohol. This is the first step, and this first step is a fast step. So how to explain this? Here in the reaction, sulfuric acid is involved. So this sulfuric acid ionizes to form H plus as well as HSO4 minus, so the ethyl alcohol is involved in a reaction which is written as CH3 CH2OH. This is ethyl alcohol. This ethyl alcohol combines with proton of sulfuric acid, where one set of lone pair of electron is transferred to proton. This particular step is a very fast step, so that it forms CH3 CH2 O with H with one more H with a positive sign on oxygen along with one set of lone pair. This is called as protonated alcohol. So we can get protonated alcohol when an ethyl alcohol is made to react with proton, where this particular step is called as a fast step, where there is a formation of protonated alcohol. Next, step 2. When it comes to step 2, the protonated alcohol which is formed in the first step, this protonated alcohol loses water to form ethyl carbocation. So this particular step is a very slow step. Hence, the slow step of a reaction is called as rate determining step. The rate determining step will be always the slowest step of a chemical reaction. So this can be explained by the equation CH3 CH2 O with hydrogens along with positive sign. This is known as a protonated alcohol, which is obtained in the previous step. Here oxygen takes away the entire bond pair of electron towards itself. This particular step is a slow step, so that we are going to get CH3 CH2 with a positive sign, because here the entire bond pair of electrons is taken away by oxygen. So this is known as ethyl carbocation. So this is an ethyl carbocation. Along with this ethyl carbocation, we are going to get water molecule as an intermediate. This particular step is called as second step, and this step is the very slowest step, which is called as rate determining step. Next one, last one, step 3. When it comes to step 3 of the mechanism, here ethyl carbocation. So ethyl carbocation is formed in the previous step. This ethyl carbocation loses a proton. Ethyl carbocation loses a proton from carbon, and that particular carbon is beta carbon, to form an ethene as the major product. Now the question comes, how the hydrogen is lost from the beta carbon. So here, this is the carbocation that has been obtained. Let us write this structure completely. So this is known as ethyl carbocation. So to this carbocation, this was the OH group that was attached to this carbon. Hence this carbon will become alpha carbon. This carbon is the beta carbon. So here from the beta carbon, hydrogen gets eliminated as a proton. This carbon is deficient. Now this carbon is electron rich. This bond pair of electron will shift between here, so that it gives rise to CH2 double bond CH2, which is called as ethene, along with the formation of a proton. So these are the 3 important steps by which a mechanism can be understood, which is known as dehydration of alcohols, or it can also be called as conversion of alcohol to alkene.